Hello everyone. In this video, we are going to discuss the dependency in pipelining, and this is very important concept. And before this concept, we have discussed the introduction to the pipelining, then the performance evaluation in the pipelining versus non-pipelining evaluation, uniform pipelining delays, non-uniform pipelining delays. So if you haven't watched those videos, plus you are directly jumping to the dependency in the pipelining, first understand those videos and then come to this particular video. So let's understand the dependency in the pipelining thing. So dependency in pipelining can be characterized into three kind of cases. One is the structural dependency, data dependency, and the third one is the control dependency. So what do we exactly mean by dependency in the pipeline? So dependency is the thing where one particular execution of the instruction is having some kind of dependency on the other instruction. So dependency creates extra cycles in the pipeline due to the dependency in between the instructions, and here the cycles are created without any new inputs. So whenever the new cycles are created, we are not having any new inputs, we are having the previous inputs only, but due to some kind of dependency, it may be structural, data, or control dependency, we are going to have some extra cycles, and those extra cycles are called as stalls. So these are very crucial, as they can increase the cycles without having the new inputs. So we must try to have reduction in the number of stalls, and if there are some stalls, we should always try how we can reduce it and how we can maximally utilize the pipeline. So in this particular video, we are going to focus on the structural dependency and the data dependency, and we are going to discuss the control dependency in the further videos. So here in this video, we are going to discuss the structural and the data dependency. Structural dependency is the kind of dependency which is created in the pipeline due to the conflicts in the resources. So we are having the resources which are in conflicts. What are the resources? Resources are the memory, resources are the ALU, that is the CPU. We are having registers, we are having memories. These are the resources that we require for the execution of kind of instructions. So every instruction will have some cycles, let's say CC1, CC2, CC3, and CC4, and in every cycle you are going to utilize some resources. So those resources may be in the shared pool, may be in non-shared pool. So we should just check whether the resources are in conflict or not. If they are in conflict, we are going to have the structural dependency. So structural dependency has the relation with the resource conflict. The resource may be the memory, register, or any kind of functional unit as well. Okay, now let's understand the entire scenario. We are having four instruction: I1, I2, I3, and I4, and these are the number of cycles that are being execution. So let's say I1 starts with memory, then go to ID, then ALU, and then memory, and the similar things are happening with the other part. So here it is only memory, no conflicts with other instructions. Here it is the decoding and the memory, so no other thing. Here it is ALU, ID, and memory. All three things are different, so no kind of conflict. But here you can see instruction 1 is also taking care of the memory control, and instruction 4 is also in the need of memory. So here this is called the resource conflict. Here we are having the resource conflict in terms of the memory. So due to this particular conflict, we are going to have the stalls in the pipeline. So how these stalls are being created? Till this point of time, we were not having any problem. We encountered the problem from CC4. In the CC4, we are having the memory for us. So that was creating a problem of the resource conflict. So we will not execute the memory with CC4. Now, when we go to CC5, the I1 instruction will go to the write back operation. And here I2 with the memory, and this I3 with the ALU. So you can see if I execute memory here, again this memory and this memory will be in conflict. So I cannot have the execution of I4 memory in CC4. So I have to wait. So there is one stall which was created due to the conflict between I1 and I4. Here the second stall is created due to the conflict in I2 and I4. And here you can see in I3 we are having again the memory. So we cannot have memory here again. So here the stall is being created due to the resource conflict of I3 and I4. And then in I3 we are having the write back, and in I4 we are having the memory. So we can just write it down in the similar manner. Now, what else we are going to have? We are going to have these stalls. And how many number of stalls we encountered here? We encountered 3 stalls, which is very costly for us. This was just about the 4 instruction, but we are not going to have only 4 instruction. We will have lakhs of instructions execution. The stalls are going to increase. So we need to take care how we are going to resolve these stalls. So the resolution of the stalls is, in this particular scenario of the structural dependency, is actually done using one technique that is called as renaming. So what we do, we just rename the resources which we are using. We actually do not rename them, we actually classify them for the specific purpose. So here we were having the memory which was actually being shared and was creating a resource conflict. So we can divide the memory into two parts. Let's say this particular part is for the code of the memory, code part, and this part is for the data part. So if the instruction is executing any code part, you can have the memory from the code part of the memory, and if the instruction is using any data part, you can have the memory assignation assigned from the data part. So that is what we mean by renaming. In this particular scene, the resources are same, but the operations are different. So here memory is the only thing in the code as well as in the data, but what we are having as different is the names. Okay, so now the both instructions can execute in the same memory without creation of any kind of conflict. So here we are actually renaming mechanism states that the division of the memory into the independent module called as code memory or the data memory respectively. So we can use that thing. So here, not having memory as the name, we are having the CM, that is the code memory. And in the same manner, when we are at CC4, we are utilizing the data. So we are naming it as data memory. We are allocating this from the data memory. So basically, initially it was only the memory which we were using. Now we have actually divided the memory into CM and DM, and whenever the need is arising, we will allocate the thing from their separative blocks. Now you will see when I come to CC4 here with I1 and I4, we are not having the conflict. With the CC4, it is DM and here it is CM. It was earlier memory and memory at both the end. So now you can see CC4 in the I1 and I4 can execute simultaneously. In the similar manner, all other execution will be done and there will no stalls. So here the number of stalls are 0. So we are not having any stalls here. So this particular mechanism is called renaming, and it is used to resolve the conflicts of the resources which are encountered in the structural dependency and avoid the creation of stalls, and will reduce the dependency, also will increase the efficiency of the pipeline. Now, the next part is the data dependency. So data dependency, it is actually created when we are having the dependency of the data from one instruction to another instruction. Let's say we are having I minus 1th instruction here, ith instruction here, and here I plus 1th instruction. So if I plus 1th instruction is using the result of ith instruction, then I plus 1th instruction is dependent on ith instruction. Okay, so this is the concept of the data dependency. So this is the very first case of the data dependency when I plus 1 instruction is using something which is related to the output of ith instruction. Also, there will be some kind of dependency of the data where there is some instruction called as ij, which is trying to read a data before I minus 1th or ith or I plus 1th is going to write it. So this particular thing is going to read something which is not yet written. So that is also called as one kind of data dependency. Data dependency issue is not created in non-overlapping pipeline. So if we are not having non-overlapping pipeline, it will be all sequential. So we will not have any kind of data dependency in the scenario. But in the overlining line of the overlapping pipeline, we are having the overlapping instruction, so that we are going to encounter the data dependencies issues there. To handle such scenario, we are having a technique that will be called as the hardware mechanism for name as operand forwarding. This is named as operand forwarding, and also it is called as bypassing or the short circuiting. So here what we say that instead of waiting, because see, when we are dependent, we have to wait for the other instruction to get executed, and then we can utilize the result. So there will be waiting time, and due to these waiting times, we are going to create the stalls. So the thing called as operand forwarding or bypassing or short circuiting says directly access the value or the new value from the interface register before the updating the register file. So we are not going to wait for the ultimate result. Whatever is being written in the interface register, just go and read the value from from there. So you're not going to wait for the entire execution. You can just intermittently take the value from the intermediate register. So we know that between the stages there are registers, and in the registers we will have the intermittent value. So operand forwarding will say, don't wait for the ith execution to completely run and execute. Instead of that, utilize the ith instructions interface result and use it in I plus 1th instruction. So this is the thing with the data dependency. And with the data dependency, we use the operand forwarding technique to remove the number of stalls that we encounter due to the dependency, either with the reading and writing of the thing or with the execution of any kind of shared data. So that was all for this video. In the next video, we are going to discuss about the control dependency in detail. That topic is little long, so that's why we haven't taken it in this video. So this was all for this video. Hope you understand everything. Thank you.